Since we were so positive in the last presentation, we're going to be even more positive now. If you think machine learning sucks now, well, I'll tell you how it sucks even more. No, it really does suck. So for those who really don't know what machine learning is, I quickly say like a few things, general overview. So many of you might think it's magic and that AI or machine learning can solve all your problems, but in reality, it sucks. You can't solve your problems. It's completely different from traditional programming or software algorithms where you basically have a sort of flow chart that you follow and where you solve your solution. Personally, I'm an engineer, so I think like that. So if something is moving and it shouldn't move, well, then I just apply duct tape. Or if it's not moving and it should move, some grease and it's be fine. So that's how a traditional engineer solves a problem, and that's how I think. And that's how most software is written currently today. So it means that traditional software is just a sequence of steps. So if you would do face recognition, it's like explaining on the telephone how you could recognize somebody. It's just like saying my nose is this big, my ears are that crooked. In my case, for example, they're different on both sides. So I could try and explain you what I look like, but if you see me in person, it will be really hard for you to recognize me. And it is possible. Like the FBI has done it. They made all these features from faces, and they succeeded in building a system to recognize faces. And if you ask them how well their system performs, you will see that in 85% of the cases, their system is able to recognize faces. So it means that in 15% of the cases, they're still wrong. So in many cases, they might think that you, for example, did a burglary somewhere, but it wasn't you, or that you killed someone, but it was somebody else. So they still make a lot of mistakes. And in machine learning, we approach this completely differently. It's actually learning from examples. So that's my kid 2 years ago now, so he's a tiny bit bigger now, and he's just mimicking basically everything I do. And he's learning from examples. He's just looking around, and machine learning is just the same thing. You just give it examples, and it just copies and replicates itself. So it tries stuff, it makes mistakes, it adjusts itself, and that whole process is repeated over time. The only thing that's important to know is when do you consider something as a mistake, as an error, and how do you adjust things? So there are many talks here that discuss how to adjust stuff, but what's really important is what do you consider right and wrong, because that will determine where your algorithm will go. I'm not going into detail on this specific thing, because I guess you all know what machine learning is, but if you optimize for something like in gamification, if you look at what China is doing, well, you can optimize for many things and your end result will be something in that extreme. So with face recognition, if you do the same thing, you just give it a lot of examples, and from those examples, you learn. Now, Facebook was able to realize an accuracy of 97-point-something%. If you compare that to human accuracy, it's actually on par with human accuracy. So the Facebook algorithm is just as good at recognizing faces as you are. I'm really bad at it, so sorry for that if I don't recognize you somewhere, but you guys are probably just as good as the Facebook algorithm. But they can do it on millions of faces. You can do it maybe, if you're really good, up to 1,000 faces, but much more is going to be really tricky. But they can do it on, well, everybody in their database. Speaking of database, well, to do machine learning, you need data. And first of all, you need labeled data. So labeled data is something that's really expensive. You need a human being to go over all the data and say, okay, this is this and that is that. And it will cost you a lot of money to get that data. So with face recognition, it's a problem because you have to label all these pictures. And at the FBI, they probably did something like that. But Facebook is obviously a lot smarter, and they approach this in a completely different way. I don't know if you guys remember, but when you posted one of your fancy pictures online some years ago, you would get like these tags around somebody's face or your own face, and they asked you to tag your friend. At that point, you were probably nice towards Facebook, and you said like, okay, this is my friend. I want him to know that I posted a picture of him online, so you gave in his name. So at that point, Facebook knew, okay, this picture matches that person, and it had a data set of that person. And all you guys, I don't use Facebook, but probably many of you did use Facebook, and you guys labeled all these faces. And Facebook started training their algorithm based on those faces. So now they have a system that is on par with human level. Whether I still like that or not, that's a different question, but it's just as good at recognizing faces as you are. So in case, it's a practical example from one of my customers, in case you want to do anomaly detection, what we have at CoScale, just really quickly what we do is we gather a lot of metrics from servers, we have this time series data, and it results in millions of metrics. So if we want to figure out where there's something going wrong on somebody's server infrastructure, well, we need to have labeled data to be able to train a model who's able to detect those strange things happening. But anomalies, they're rare and they're always different. So each time you have an anomaly in your database you can train on, the next anomaly can be completely different. So even if you annotate all the data that you have today, the anomaly of tomorrow can be different. So there is no way of labeling the data, even if you had the manpower or the money available to be able to do that. So there is never enough training data, but there's one thing that you can do, and there are always these kinds of tricks that people use in machine learning, is that the expected future is really predictable. Everybody can finish this sentence, right? It's really easy if you know what's going to happen to finish the rest off. So what we do is basically make a prediction of what's going to happen the next day. So just quickly, you have these 6 days here, they're the past. The green line that you see is the average of what's happening the past 6 days. So the next day we will say like, okay, we expect the data to be like the green line. But we noticed like in the past there were some changes to the data. It was not always exactly the green line, so we put a boundary around that and say like, okay, it should be within that that pink boundary. And then we can say like, okay, if it's not within that pink boundary, then there's probably something wrong and there's an anomaly. And that's the same thing you can do. You just predict the future and see if the future matches reality, and based on that you can do anomaly detection. And it's in machine learning, it's always this kind of tricks that you have to do if you don't have enough data to get more data. Another thing that's really important that you need is clean data. So this is also a slide that I stole from Andrej Karpathy. He works for Tesla, so he works on the software for self-driving cars. He's actually a famous researcher in machine learning, so they hired him. And he said, during my PhD, there was barely any time that I spent on cleaning up the data and making sure that it works all right. But currently in his job, and he's leading a whole division, he spends about 75% of his time looking at data, cleaning the data, and doing something with it. And probably what he's doing is looking at, for example, traffic lights and saying like, okay, this is a red light, so you shouldn't turn left here. But apparently there's some arrow straight forward, so you can go forward and still drive on. So he has to label all that data, and it takes a lot of human work to be able to do that and to clean that data. So he might waste like 75%, but if you start messing around with data, you can be quite sure that you spend 80% of your time cleaning your data. And then a last thing about data is that you need a lot of data. So humans, they are made for face recognition. We are pre-programmed, genetically pre-programmed to be able to be good at face recognition. Sometimes it fails, like in my case, but most people are really good at that. But for machine learning, it's the same thing as classifying rocks. So if you have two different rocks, as a human, it's going to be really hard to recognize that one rock among a whole room of rocks. But for us, when there is one face among this room, and if I know you, I will be able to recognize you. But with rocks, it's really hard. So for machine learning, it's actually the same thing. So if it has to learn to recognize faces, it's like what we have to learn to recognize one rock from another one. So that's why you need a lot of examples, because the system is not pre-trained to recognize rocks or faces. You just need a lot of examples, and then it will learn, okay, I should look at the nose and the eyes and the ears, and that's what's important. Not just the hair, because it changes maybe every 2 or 3 months. So once you have your data, you will probably run into a next issue, overfitting. Overfitting is the single biggest issue there is in machine learning. If we solve overfitting, then, well, forget your job. Like there are no more jobs. Like machine learning can do everything. As long as we're overfitting, we have a job, so that's good. But apart from that, it's the biggest problem you will encounter as a machine learning engineer or looking at people working with machine learning. So with face recognition, let's imagine you build a system and all of a sudden you think you have struck gold and your test results show you that your system is 100% accurate. Well, at least on your own data set, because that's the data that you have available. But when you give it new data, you might see that this horse right here is classified as Donald Trump, or the other way around. I don't know which one is worse, but so your system might have seen that, okay, some, well, pony hair flowing through the air, that's probably a horse tail or Donald Trump. So it doesn't know the real difference between, well, the back of a horse and the face of Donald Trump. And that kind of things, it's funny now in this picture, but in reality it happens all the time. You will run into overfitting all the time if you work with machine learning. So what happened? I'll quickly show you some mathy stuff. I illustrated so that I don't need to show you any equations. But let's say you want to model a sine wave. So the sine wave is this curly thing right here, and the only thing you get are these 10 blue dots. So as you see, these 10 blue dots, they are not perfectly located on the sine function. Why is that? Because all data that you measure, there are measurement errors. No data is correct. So let's say you try to model this. So the simplest thing you can do is, okay, I'll figure out a straight line, and this straight line is a model of my data. But as you can see, the straight line looks nothing like the sine function, and if you measure how well it fits, it's 45%. But let's say you use, instead of 2 parameters, let's say you use 3 parameters in, for example, a polynomial function. And then you see the fit increases a tiny bit, but you're not there yet. But with 4 parameters, you see like, okay, this more or less looks like a sine function, and my fit went up to 93%, so that's good. Maybe we add some more parameters. And we go to 95%, 96%, 97%, 98%, 99%, almost there, 100% fit. So we made a model that can fit this data 100% perfectly. So if you look at this graph, well, it doesn't look like a sine function anymore, does it? So something went wrong, but it fits the data 100% correct. So if you run into this, keep calm, because perfection doesn't exist. It doesn't exist for humans, it doesn't exist for machine learning. What you have built at this point is a data storage system. Very inefficient, but you had 10 data points to build your system on, you used 10 parameters, and the only thing the machine learning algorithm did was store those data points, and it didn't care what the rest of the data was looking like. So you get something like this. So how do you avoid overfitting? Well, the easiest way to avoid overfitting is getting more data, but you know data is really expensive, and it's really hard to come by because humans need to label it. Another trick that you can do is use fake data, artificially generate some extra data or do data augmentation. It's an old field of research, but just to explain what data augmentation is, instead of taking the normal picture, you might stretch it, rotate it, or do something with it so that you artificially create extra data to learn from. But the best method there is to avoid overfitting is just to keep it very simple. And in this case, instead of using 10 parameters, you just use 4 parameters and the model works more or less fine, and it seems to fit very well. So okay, you have built an interesting model. So now you wonder like, okay, so how can I extrapolate this? Can I look beyond these borders and see what happened? But if you try to do that with that same model I showed you earlier for the sine function, and you go to numbers in this case below 0 or above 6, then you will see that this model can't know this data anymore and just puts out something randomly. So what you always get in machine learning is that if you look at a certain specific field of data and you train your model on that, it's really hard to let it work on another set of data. You cannot transfer that knowledge to a new area. It's really hard to do. And in most cases, it won't work. So you have to give it examples of things that it will encounter in reality. It sucks, right? So machine learning only works on similar data. Okay, features. So let's say you think of a very good feature. So for the example I showed you, if you use the sine function of x as a feature, well, you don't need any parameters anymore. You can just use the sine function because you know the relationship between input and output. And in this case, even though the data is noisy, you get a 98% fit, so that's really nice. So in face recognition, what you can use as features is, for example, the color of your hair, or maybe if you're Donald Trump, the color of your skin, then you know, like, okay, if he looks orange, he's probably Donald Trump. So how do you find these features? How do you get them? One approach that you can do is brute force. So actually in deep learning it's more or less brute forcing it, although people will not agree with me, but you just make the system learn and find these features. Or you can have just a big set of features and say like, okay, let the machine learning algorithm select the best one from those features. But having a lot of features makes your model more complicated. It will have more parameters. So if you have a model with more parameters, you will get a model that is overfitting because it's much easier for the model to just store the data than to really understand what's going on. So what you want is only relevant features. And well, to find relevant features, you need to do engineering. You need to figure out what the relationship is between input and output. So in order to be able to do that, you need to understand your data. And you need to be able to turn whatever you measure somewhere else into a number that your machine learning algorithm can interpret. Earlier this morning in the keynote, we had a brief introduction into adversarial examples. So you can just add a noisy image to another one, and instead of thinking, for example, this is a dog, you add this kind of noise and it will think it's an ostrich. So you can fool this system, like you can fool us with illusions, but it's the same thing. So there are ways to avoid this, but these techniques are not perfect. One of them is data augmentation, but as you might have guessed, this is an entire field of research. So a lot of people are looking into it. How do we can avoid it and make our systems more stable? But even if you are able to solve some of these adversarial examples or make your system more resilient, there is always a risk that at some point somebody figures out how to fool your system. Just like you can fool people into voting for somebody who's not very good for your country. So, technology. If you look at the number of AI papers published in research, well, you see that it's skyrocketing. A lot of researchers are working on it, so you might think, okay, we're gonna crack this, we're gonna break this. But at this point, we're not there yet. But we are able in very specific tasks to work really well. So in image recognition, we are actually able to surpass human level. It might not seem like that when you use Google, but in a theoretical framework on specific data sets, we are able to beat human level. So many tasks become really easy. And what it will get is, well, we can replace a lot of tasks with machine learning, but still as a machine learning engineer, so I'm looking at most of you guys, it's hard to keep up because you have all these new technologies, all these new papers coming out, you have to follow suit with what's going on. So I hope that's why you guys are here, because the point is that we share all the information that we've learned with you guys and that you can go home and start messing around with it and hopefully next time bring us some interesting information. By the way, there is a call for papers, so feel free to send one. So, job market. So, if we are replacing jobs and we need more in machine learning, there's probably experts that are required. Well, if you look at monster.com, the number of published job openings, you see that machine learning or deep learning engineers are in high demand. So if you are in this field, don't worry, there are a lot of jobs for you guys. But for other jobs, it's completely different. If you look at the amount of robots that are imported in Western countries in general, you see that it is skyrocketing like crazy. So a lot of people's jobs are replaced by robots. So one of the companies I sometimes work for is RoboVision, and they have these machines that you see here. They are able to pick up a plant and plant it somewhere in the soil. So they have a visual recognition system to recognize where to pick up the plant and put it in the right spot. So you see 12 machines standing right here and 2 people operating this machine. In most cases, actually, those 2 people are barely doing anything, but they used to need 24 people to do this job. So you can automate a lot of stuff. So also jobs of many friends or people that you know will be able to automate. So which jobs will disappear? Well, many tasks can be automated, as I said earlier. So actually all repetitive jobs will disappear. So if you have a part of your job that is repetitive, it will disappear and will be automated at some point. And if you want a list, well, it's very hard to make a full list, but driving, accounting, many jobs in banking, packaging, garbage collection, line work, whatever you can think of, all these jobs will disappear. And I like to pick out, since we are in München and in Germany, I like to pick out one case, self-driving cars. So I think most people of you own a car or at least drive a car every now and then. And for me personally, cars are fun. I like to drive a car. But my car stands at least 95% of the time, it stands still, doing nothing. It costs, on average, if at least these numbers come from Holland, on average a car costs you 650 euros a month. So every month you pay, well, you have the down payment on your car, so it loses value every month. You have to maintain it, you have to fuel it, there is insurance, there are some taxes. So you have all these things, and it's not fun. It's not nice to refuel your car or to maintain your car. It takes time that you don't want to lose. Well, self-driving cars, they are obviously all the hype, but they could actually drive, well, if they would drive 100%, they would drive 20 times more. But let's say they stand still at night. So they could drive 10 times more. And if you make the calculation, they can actually cost you, instead of 650 euros, you can probably have all your transportation below 100 euros. So it means that it will cost you at least 500 euros a month less to be transported somewhere. They need less maintenance because their business model is completely different, because now BMW makes money on maintaining your car, but if 2 suppliers are competing to provide self-driving cars, the one with the less maintenance, well, can do the most transportation and will probably be the car that works. And trucks, for example, so the big trucks, they can do millions of miles without any maintenance. So it is technically possible. And they can refuel themselves, you don't need to pay any attention to that. So it also means that if we have self-driving cars and we need 10 times less cars because they're not standing still anymore, that most likely 9 out of 10 car companies are going bankrupt. So for those of you working for car companies, think about this, because it might be that in 10, 15 years, your company that you work for doesn't exist anymore because there aren't that many cars anymore. On the other hand, okay, it doesn't suck all the way in machine learning. It will give us a pay raise of 500 euro a month because we are no longer paying for a car at this point. And in my opinion, there are a lot of jobs that will remain. Machine learning engineers, you'll be fine for a while, I guess. But to be honest, to give you a general impression what machine learning is not good at, why it sucks, is because it's not good at doing something new, something it hasn't seen before. It needs many examples. We are pre-programmed to be able to do a lot of stuff that machine learning is really bad at. So what are we really good at? It's combining multiple sources into new and unforeseen ways. And we are actually really good at this from childhood. I don't know if you remember your own childhood, but if you have children, you will recognize this instantly. Like these kids with maybe a stick, they think it's a sword or whatever, and they make the most fun things out of it. They are really able to recreate their environment into something new, something they imagine. And we humans, we are good at it, but we stopped being good at it because we went to school, most likely, or we grew up, I don't know. But in my opinion, we need to change the education system that we keep this ability that we humans have to be creative and to make new things. So, democracy, we already highlighted this. So we have China, I'm not going into that. Cambridge Analytica, there's no news there, so it gave us Brexit and Donald Trump. But as also mentioned, there are also big companies that know almost everything about you. So if they want to control the society, they can do that. They have the ability because they know everything there is to know about you. But we had enough of that already, I guess, or maybe never enough, I don't know. But maybe there are startups who can solve this problem. But if we look at what's happening in startups, you see that it's skyrocketing. Like, okay, this slide is from 2016, but the number of startups in AI is increasing exponentially. But on the other hand, if you look at the funding that goes into these startups, it plateaued at some point. So in 2013, we put in more or less the most amount in as VC funding into startups. And at that point, all these extra startups, they're not getting more money. Which means that investors have realized that all this AI magic is just magic. And we should really think about what we're doing and not just throw our money at any company that claims AI, or what you see happening nowadays with a company that has the word blockchain in its name. So, to be honest, AI winter is coming, or it's already here, because investors have realized that there is a big issue with AI, that those startups that promise so many things are not realizing what they promise. And why is that? If you ask me, is because they haven't got the business question right. So the business question is actually very simple. Why machine learning? Why would you do machine learning? And if your answer to that question is everybody else is doing it, or they're talking about it so much, I guess you have the wrong answer. Because why is everybody else doing it? Is it because it's cool? To be honest, your customers don't care if you use machine learning or any other fancy technology. They don't care. They want to use your product or your service the best way possible, but how you do it, they don't care. They just want service or a good product. And to give you an example is chatbots. So whoever in this room used a chatbot, please raise your hands. Okay, so who of you liked it? Somebody? Not even like, oh, okay, one guy. Can you tell me why you liked it? Perfect reason. That is the perfect reason, because in essence, chatbots are cool, right? If you can make a computer talk to yourself, I mean, that's cool. So you have these chatbots like Siri, Cortana, Alexa, many of them. You have an entire ecosystem around it, companies that offer these kind of things. But honestly, I don't like talking to a chatbot, and most of you guys don't like it unless, well, you build it yourself, right? So what are good reasons to use a chatbot or to use any other technology like machine learning? And I think the main question at this point you need to ask yourself is, why does my company exist? Why am I here? What am I doing as a company? And the simple question is, a company exists because they have customers. But if you don't know your customers, what are you going to do? So you need to think about what your customers value. What are they willing to pay for? Well, maybe your customers value money, and then they want the cheapest possible product. So everything will be cheaper. Like with self-driving cars, cars will cost you 500 euros a month less. So it gives you a pay raise if you use machine learning for that. So that's interesting, and customers will want that. But if you look into the business of cost cutting and making sure that your company is cheaper than your competitor, you will also see that the companies that are best at cost cutting, that they have lower profit margins. Except Toyota is maybe an example that is really good at cost cutting and still making huge profits. But in most cases, once you start going into the cost cutting game, you also start cutting your profit. And especially the size of your profit, because everything becomes cheaper and your revenue decreases, so the amount of profit you make will be less. So what you need to think about yourself is, what can I make money on? Because, I mean, if it's just the game of making things cheaper, it's interesting because you help a lot of people so that they are able to afford a lot of stuff, but there is more than just that. Well, my German is horrible, so I'm going to let you read this. So I'm going to translate it to English. So Bertolt Brecht at some point said that first you need to fill your stomach, and after that you can think about morale. And I think it's a very good phrase explaining what's happening, what you see with millennials. Because they grew up in an environment where they basically have everything. Not just food, but also shelter, healthcare, probably very good parents. But at some point, they start thinking about other stuff, about morality. So I think we're going into a value-driven economy, where values, whatever they may be, will become more and more important. So what are these values? If you ask me, and it's really personally dependent, it might be the environment, animal rights. For example, in Belgium, when I was like 20 years ago, when there was animal cruelty on TV, people were like, okay, yeah, that's the meat industry, it's normal. But currently, if something happens somewhere, and I think the Belgians in the room can recognize this, if they show like how a pig is beaten with a stick, well, when I was young, it was okay, but if you see it today, it's like, this is cruelty. I don't accept this anymore. So you see that these social norms are evolving and that people don't like to cause harm to the environment, to animals, and humanitarian reasons. On the other hand, people might want delight, they might want to be surprised, or they might want a system that predicts when, for example, you will run out of washing powder or whatever, so that you don't need to order it. Or maybe you just need something, like a good bed to sleep in and you don't want to think about it, and maybe the machine learning algorithm can figure out for you what a good bed is like. Healthcare. Maybe you don't want to get ill. Maybe, you don't like going to the hospital and you want to make sure that you never have to go to the hospital. Or you're just sick and tired of cleaning your house and you want like a vacuum cleaner or whatever toy to clean your house so that you don't have to do it and you don't have to pay a human to do it. So in conclusion, machine learning is not the solution to your problem because it sucks. It might help you out, but it's not the solution to your problem. What you need to do is get to know your customer, and then you will know only at that point which technology will be able to solve your problem. And on the other hand, you also need a lot of data if machine learning happens to be the technique that you will need to solve your problem. So only then when these conditions are met, you can make really big leaps forward with machine learning. You need to know what your customer wants, and if machine learning might be the solution, you need a lot of data to be able to do this. So personally, I'm working on a new startup called healthskouts, where we basically try to predict when you get ill. To be able to do that, we need to gather a lot of data. And for privacy issues, this is not very simple, because we need to show people that the data that we gather is going to be used in, well, for their benefit and not just for making money. It's a tricky one. But still, machine learning sucks, but personally, I really love it. I hope you guys also love it. Thank you.